It was actually I think 2006 that Rosa and I met for the very first time at an EU Hands-on Universe. There was a EU Hands-on Universe was a grant that ran for a while that I think was Salsa J was one of the main products of that. But there were so many resources developed during that. We were in Naples doing a teacher workshop, and my life has changed irrevocably for the better having met Rosa 18 years ago, I think that was. And the same year, I met Carl at an ASP meeting. And for the whole week, Carl called me Cedric. Um, why, I don't know, but that's lost in the mists of time now. But occasionally he does get my name right now. Las Cumbres Observatory. Why? Oh, I'm getting a message. Um, why build a network of telescopes? Well, this is an all-sky camera that I installed on Cardiff University's physics building back in 2013, and it really highlights why we need telescopes in all sorts of strange locations. This is a beautifully clear night. You should be able to see stars, Milky Way, and the only thing that you can see are street lights, lights on buildings, and down here there's a dot, and that dot is the moon. And so we put telescopes because we can't really do much about the street lights. So you can do it, but it's extremely frustrating. So we put telescopes in a variety of locations, far away from streetlights, far away from dense populations, and at the top of mountains to give them a fair chance of having a good weather. And this is one of our telescope installations on the island of Maui on the mountain Haleakala, the arrows pointing out amongst the other observatories. And then you get a view that's like this, the same all-sky camera. This is a picture yesterday of the sky, and you can see the Milky Way there. And if you've got very keen eyes, you can probably pick out some constellations as well. And just, you probably can't see my mouse, but in the lower left portion is that clamshell. So you put your telescopes at the top of mountains and you enjoy fantastic views like that. But sometimes you get fantastic views like this, where it's just snowy for several weeks, because you're at the top of mountains and you get snow sometimes. So to stop you from being hindered by this, you build a telescope network. And that's what we did with Las Cumbres Observatory. We have a global telescope network of 25 telescopes arranged in 2 rings in the Northern Hemisphere at 4 sites, Hawaii, Texas, Tenerife, and Israel, and 3 sites in the Southern Hemisphere, Chile, South Africa, and Australia. And the telescopes that I've highlighted there are our educational network of 40-centimeter telescopes. So here are our currently operating telescopes, 2 meters, 13 1 meters, and 10 40 centimeters. And actually there's a mistake in this because these telescopes are not 40 centimeters anymore, because last year we removed all of those telescopes and we replaced them with plane wave delta Rho telescopes, are actually 0.35s, and they have fantastic cameras on them now. And these are the telescopes which form our educational network. Here's some proud dad pictures, if you like, some pictures of these beautiful telescopes in their situations. But we designed all of the 2 meters, the 1 meters, and we bought the optical tubes are off the shelf and the cameras are off the shelf for the Delta Rho, for the smallest ones. But we still made the mounts, and the South Africa picture shows you that mount there. The idea behind designing the mounts for these is so that they would be endurable. They would last for whatever situation we had, and they would last for a good amount of time. And although we replaced the telescopes, those mounts were still good to go. So we just dropped those new telescopes into those mounts and they just carried on. So I'll talk a little bit now about the science that you can do with these. And then in the second half of the talk, I'll talk about some of the amazing education projects that it's been my privilege to be involved with. With a network, a global network of telescopes, as you saw in the southern and northern hemispheres spreading out around the globe, you can do time domain astronomy, astronomy that of things that are changing. And one of the best examples of this is the follow-up of gravitational wave events. This is something that has been called multi-messenger astronomy, where you've got not just photons, but there are other messengers sending the exciting information about these astrophysical phenomena to us. And in this case, gravitons, but it could be other things, neutrinos and particles. So back in 2017, cast your mind back seven years ago. That's the year that my children were born. So that's significant for me already. There was a gravitational wave event that LIGO Virgo picked up. And that coincided with a gamma ray event. And this was very exciting because normally when you get a gravitational wave event, if it's the merging of two black holes, the light from it looks like this. There is no light. So it's extremely difficult for us to do follow-up of these type of things. But people thought, well, these are massive bodies colliding. They produce gamma rays, so they're not black holes. They must be neutron stars. Well, we know something about how supernovae are formed. So we'll go ahead and look in galaxies, because as you can see, that's a large fraction of the sky there that you'd have to survey. So by looking in galaxies, and several of my colleagues and observatories all around the world started this hunt for this optical counterpart of a gravitational wave event. And there's that picture again. You can see that inside this localization, the blue blobs, there were galaxies. And so my colleagues in LCO started this process of taking observations of these galaxies. You can also see in this picture the full moon. So you can see exactly how big this area is. You don't have to survey the whole sky, though. The bits without galaxies are much less interesting. And my colleagues surveyed 30 galaxies in 12 hours to try and find the one that had the exciting optical counterpart to this gravitational event. And they found it. It was the kilonova there in NGC 4993. And that's really quite amazing. It was actually the 5th galaxy that they'd observed on their list of 30, but it takes a while. You take the observation, just carry on going, and then you do the processing while you're doing the observing. And here's the before and after. There's the DSS image, and there is the LCO image on the 18th of August, 2017, 15 minutes past midnight. We got it. But unfortunately, 45 minutes before, a different telescope had taken an observation of this galaxy. So we weren't the first. But that doesn't matter. You know, science is science. We all contributed towards this amazing discovery of the kilonova. But LCO did have a significant role to play. Because we have 3 sites in the Southern Hemisphere, we were able not only to capture, and this target was very, very low. So there was only a very small window that you could observe it. I think it was only about 45 minutes before the target set after sunset. So you had a very, very narrow window to observe it. And we observed it first in our site in Chile, but then we picked it up in Australia and then in South Africa. And the significance of that is, as you can see from this graph, that the kilonova was still brightening before it started dimming again. And that was really, really important for understanding the physics of this kilonova event. And you can see here this illustration of when data was taken over the following days after that amazing discovery. So that shows you the power of not only having these wonderful telescopes in fantastic observing locations, but of having a network of telescopes and actually having a robotic telescope network, because we could launch this campaign not from an observatory site, but from the comfort of the observatory headquarters in Santa Barbara. Another exciting part of time domain astronomy was the DART mission, the double asteroid redirection test, where it was a NASA mission that I'm sure many of you are aware of, to redirect an asteroid by driving something into its moon. So this asteroid had a moon that was going around it, and by adding angular momentum to the moon, you push the main asteroid off track. We had a big campaign with our solar system researchers to observe this, and this is an animation of observations from immediately prior all the way through the impact. And you can see this plume of material that shoots out. It's not as long-lasting as if it had hit a comet, say, where there's a lot more material, but you can see there that clearly something has happened to that asteroid. So we had extremely valuable measurements of this event that we sent to NASA and to the international collaboration team to understand more about not only the way that the trajectory had been changed, but also you can learn some interesting physics about this asteroid from the material that's outgassed after the collision. But we were extremely fortunate to partner with a group called Comet Chasers that also wanted to be involved with this, and they used our telescopes, and they got school kids involved. And here is some observations a month or so later of that asteroid, and you can see the material has left a trail behind the asteroid as it's moving through space there. And the wonderful thing about this was that the students that were involved in this project, and this is them being extremely excited and holding up copies of the paper that they were mentioned in. There's really nothing like that type of experience for children to be involved in such an important, not only an important measurement, but a significant measurement, but also something that was in the news so much. It really is so inspirational to them and gives them an experience that they wouldn't have if it weren't for robotic telescopes. So those are two examples of the science that you can do with them. I'm going to talk now about the educational work that you can do, and maybe a little bit of social enterprise. But before I talk about robotic telescopes, I just want to tell you about a couple of resources that we've developed. One is Ada's Adventures in Science. You can go to that URL and download copies of Ada. Hopefully many of you have already heard about Ada's Adventures in Science. It's a comic book about science to empower, excite, and inspire children to do science. Not necessarily to become scientists, but just to start thinking about things, because we really need a population that is scientifically literate. Those are the people that will be voting for politicians, that will be working in different industries, and we need them to be scientifically literate so that they can make good choices. And in a small way, Ada's Adventures in Science aims to do that. We recognize that in the switch between primary school and high school, kids stop asking questions. I've done many, many workshops in primary schools and high schools. And in high schools, the kids, except for a very small number, don't want to be involved unless you work really, really hard in small groups. But in primary school, all of the kids want to be involved. They're all excited, they're all asking questions. And so this comic book is aimed at that transition to show kids that the most basic part, the most essential part of science is asking questions and being brave enough to ask questions which people might consider stupid is actually what makes you a great scientist. So please, I would love it if you had a look at Ada's Adventures in Science. Ada's Adventures in Science. It's now available in 18 languages. If you notice that a language that you speak is not represented on the website, because obviously all 18 aren't there, please do be in touch if you'd like to help us with translating it. Another effort and educational program that we ran and continue to develop is Serrel's Cosmic Explorers. This is aimed at younger students, primary school age students, and it sets them off on their very first experience with using robotic telescopes in education. We have a very nice website with videos that my colleague Alice animated herself. We have some games, but fundamentally it's about taking pictures with robotic telescopes in a highly simplified way, and then doing a little bit of an investigation afterwards. So they answer questions about what they can see in their image. And I would, again, this community is the perfect community for sharing this resource. And I would love to hear any comments that you have about this resource and how you could use it for astronomy education. But the largest program that I want to tell you about is the Global Sky Partners. This is our way of creating a sustainable, scalable, and high-quality education program using robotic telescopes. We partner with groups and organizations who provide fully supported educational programs. Some of them have a strong track record, and many of you are here actually, like Carl and Bonnie, who have been part of this program since the very beginning. But others just have a good idea, sometimes a crazy idea, and an audience, and have a plan on how they're going to support them and the education that they want to do. It's a totally free program. We have an open call to anybody in the community who wants to be involved. Every year, we ask the community to send us proposals for a project, and then they are judged by an independent international committee. I'm not part of that committee, it's independent. But there are 3 key points that we ask for in the proposal. We would love it if these projects are for underserved and underrepresented communities. I feel it is an obligation that we have, me in particular, as living in a Western country where I have tons of opportunities to provide opportunities for people who don't normally get involved in these type of programs, who don't normally have the support that they need to be part of a program like this. Using professional scientific instruments is something that could change the life, the career, and the well-being of people all over the world. Because we have an innovative telescope network, we ask that the programs could be innovative in some way in their use of the robotic telescopes. And fundamentally, they have to be educational projects. And when I say educational, I don't mean Astro 101. I mean, if they are for university education, they have to be in the developing world, not in the global north. So those are really the 3 criteria, and it's an open call. And I have been blown away in the last 7 years on how many programs have been involved, the high quality of the programs, and the diverse nature of them. And I'm going to show you a few of those programs now. Some of them may be familiar to you, like this one. This one is run by our dear friend, Bonnie Thurber, who's with us, I think, on the call. The Moon Over Us, where she works with groups all over the world. I believe it started in India, but she's branched out into other places now. And it's a program talking to teachers about the moon, something that is the perfect object to get people looking up, because the moon always delivers. You don't need anything other than your eyes to see the moon, even in places with extremely bad light pollution. But then if you look at the moon with binoculars, it changes the way that you see this object forever. And so this is a STEAM project. There's STEM and art in this project of getting people to share stories about the moon, getting people to do art to do with the moon. But as part of it, they use LCO to take pictures of the moon. And this was something that Bonnie was desperate to do for Bonnie had been involved in other programs with LCO, and she came to me and said, "There's no way for us to observe the moon." And I said, "Yeah, of course, because the moon moves differently to everything else, and it's very bright, and it would be crazy to point a robotic telescope at it." And then I thought, well, Bonnie has this amazing program, so I adapted our observing interface to take images of the moon, and here are two of the images of the moon with our new Delta O telescopes that were taken in as part of Bonnie's program. Not only did Bonnie have a request that I worked with her on achieving that, but also this has meant that everybody can now take pictures of the moon with Las Cumbres Observatory. Another one is the Institute for Student Astronomical Research. Now, this is a very different program run by Rachel Freed. It takes students on a journey of investigation where the end product is writing a peer-reviewed scientific paper. These students are high school students, not undergraduates, although Rachel does run this with a variety of different people. The students do double star measurements initially, and then Rachel will mentor them in the art of writing a scientific paper. And it's really quite amazing what these students can achieve. Many of them start off on just a double star project, which is a very simple measurement. You take an image and then do a very simple measurement. But it's what you do then afterwards that they are trained then. And they are trained not only in the writing, but also in the scientific process. And this method is used by actually many of our other partners in their programs, along with doing other things. And Rachel is really the backbone of that program, of supporting those other partners. One of those other partners is Boyce Astro. They are a real powerhouse partner. They not only support hundreds of students to do original research, but they're one of the key partners that support other partners in this program. And I can't emphasize enough how much of a community this is. We can't do this alone. None of it. Hands-on Universe is a shining example of how we are all better if we work together. And Boyce Astro is one of those partners. It's a real linchpin that they provide support to other partners, particularly inexperienced ones. So in the pictures here, you can see one of their groups that they've mentored, and on the right side, you can see two of their students at a professional astronomy conference presenting their results of work that they did using LCO observations. It's really quite amazing to me to see these students grow in confidence and doing this original research. Beyond the Stars is of a very different scale. It has its target audience is quite small, but the level of impact is extremely high. It's targeting an audience or audiences in the Canadian Northern Territories. Again, this fits perfectly into the underrepresented and underserved communities. The idea behind Beyond the Stars is it's a two-way exchange. So the scientists engage with the indigenous population to exchange stories about the stars and about the night sky, so that the scientists tell the scientific stories, And the people in these communities tell the indigenous stories of the night sky and the law of the heavens. These places are often inaccessible by road. So initially they had to do the mentoring via the internet. And there are many problems to do with that, not least because Starlink internet cuts off at 2 p.m. in their school. So they have to do everything within a shorter time. There are other challenges. This is a community of young people that they were working with that were extremely disaffected. The school had a high level of truancy. They also had high levels of insobriety. The students were not engaged with going to school. They were not engaged in learning. But through this program, which is a STEAM program, they found that when they were doing the video calls, that the students, the scientist Heidi White said to when she was talking to the teacher, the students look like they're just not enjoying it. They seem to have really angry expressions. And the teacher went, no, 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 you misunderstand. That is their thinking face. They have never been more engaged than they have been with this community, with this program. And part of that is because somebody cares about them. Somebody cared enough about these students to want to have not only a single intervention, but one that was over a period of time. And eventually Heidi went up to this region and was blown away by the students who didn't want to go to school were all turning up to her workshops and turning up to school that day. That in itself really emphasizes the importance of the work that we all do. And finally, I couldn't give this talk without mentioning a fantastic program by our friend Patrick Miller, who runs the Isaac program. The deep sky images, I won't embarrass myself by trying to pronounce the Portuguese, is a program that runs in all 26 states in Brazil. The aim of the program, which they have achieved over a 3-year period, is to train teachers, 1,000 teachers in using astronomy as a tool for teaching science. So they start off in a very introductory way by inspiring the teachers by just taking pictures with robotic telescopes and coloring those images in a 3-color image. And then they do a little poster presentation about the object that they've chosen. And they've been running this in hybrid because it's not been possible for the team to access all 26 states. But where they can travel to the states, they do. You can see in the bottom right that the teachers then go into the schools and then they run the workshop that they've had with the students, and these students that are doing their own poster presentation of the 3-color image that they took. On the bottom left is quite an amazing picture. The Ministry for Technology and Innovation, and the minister, I think, is sat with his back facing us, endorsed this program. And as part of that endorsement, they invited all of the teachers to Brasilia to an award ceremony for this program. And as many of them as could get to Brasilia are filling that picture. Really quite amazing. From that point, the teachers can then go on through their curriculum. So go on to the Isaac curriculum and finding asteroids. And some of them have even gone on to the national and international astronomy Olympiads, all from that very humble beginning. But that really shows you that it's really the seed. If you get that first intervention right, you can really set the students and the teachers on the road to something quite amazing. During 2023-24, the direct audience of this program has been 15,600. So that's the teachers, the number of teachers, and the number of audiences that were directly involved in the programs. If you scale that up and include the teachers who then went back into the classroom and they had an impact on their students, that number goes up to nearly 60,000, the direct and indirect. I could never have run a program of that scale and of that diversity and of that high quality by myself, because that was the choice that I was faced with. I have all this robotic telescope time. Do I keep it all to myself and run it all myself, or do I get people who are really experts to use these telescopes and give them the time for free and just see what happens? Our geographic impact has been improving over the years as well. We started off very heavy on Northern America and Europe, and the one on the farthest right, this area in the green box is Africa, Asia, and Central and Southern America and the Caribbean. And those areas have been increasing, which is exactly what we want. We want to give these opportunities to groups that wouldn't normally have them. And robotic telescopes are the ideal instruments for this. In the last year, the audience demographics have been nicely split between teachers and high school students. So just in the last couple of minutes, I'll share with you some of the achievements of this program. We've been involved in follow-up for TESS, for Gaia, for JWST, for the Minor Planet Center. Students have made presentations at international conferences, state and county science fair winners, and dozens of workshops have taken place with in excess of 1,000 participants globally. In the last year, 20 papers have been published by high school students in the Journal of Double Star Observations, and 4 have been published in other peer-reviewed journals. Over 110 papers by high school students have been published since the program began in 2017. These are some of the pictures of students presenting their work at international professional astronomy conferences. There were 18 talks by students. I can't imagine doing this when I was a high school student. I couldn't even imagine doing it as an undergraduate student. The confidence that these students have, not only in the work that they've done, but then in themselves to present this, is really quite astounding. And every time I see this, it really blows me away that in a small way, we helped them achieve these goals. This year now, so we started 1st of August, we have 35 partner programs running. I think this is the largest cohort that we've ever had, and I only feel empowered to have that many partners because we have so many great partners involved that they support the people who are inexperienced in ways that I could never support them. They use their experience in education, their resources that they've developed, and they very generously share them with this community. We meet once a month, and the discussions that we have are really some of the most interesting that I've ever had, and in science and in social enterprise, really. You can find out more about all of the partners that we have here. And also, if you want to be involved, there are ways to join us now. You don't actually have to wait for the annual call. If you want, if you have an idea for a program that you think could use robotic telescopes, we would love to help you. So with that, I'll just say thank you. And it's not only thank you for you for listening, but it's also a huge thank you to all the partners, because it is the partners that make this program. Without these partners, we wouldn't be able to achieve anywhere near as much as we have. And it's the partners that really make my life so full of joy. So Thank you.
Wow, Edward, that was amazing, amazingly well done. Well, so proud of, having seen this being born. And I really am blown with the achievements. I didn't know you grew so much. I knew you were big, but I have to admit, embarrassingly so, that I didn't know that how far you've gone. That is absolutely amazing. And actually, I think this is all that Global Hands-on Universe stands for. So I think we are very lucky to have you as a partner.
It's
I
my
think
pleasure.
we open the floor to questions and comments. Do we have anyone in the audience willing to ask anything to Edward? I don't know, Gustavo, are you watching the Facebook page to see if anyone there?
Yes, I'm watching. I have people on Facebook, but
Okay.
there's a time lag, right? From the
There's a time
stream.
lag, right?
Yeah, it's like
right,
1-2
right,
minutes.
right.
So we
Right.
should start here with the Zoom audience.
Yeah, so I don't see why people are thinking about the questions that they are just sending lots of compliments, as you probably can see. I just wanted to say I just came back from a conference in Brazil, and we hear echoes of what's going on there in terms of achievement of Isaac and LCO and everything else. And I think even though you have some kind of idea of what is the reach and the impact on those students, I don't think you have the 100% picture. It's a life-changing thing for many, many, many of them. You have no idea how important these programs are for them. And I suspect the same goes for everyone, not only in the developing countries, but in the developed countries as well. These are opportunities that are changing the lives because it makes humans feel, I can do that. And this is a message that is not always conveyed. So,
Yeah, it is about that empowerment. That's one of the things that I feel is the overarching theme with all of the projects that I've been involved with. It's really empowering people because everybody can do science. Everybody can do it. People think that they can't do it. And some people have difficulties with maths, okay? But that doesn't stop you from being an amazing scientist because I see my children who are both 7 and the questions that they ask, they are scientists and children forget how to do it. They forget how to ask those questions. And it's all of these programs are our way of sort of reassuring them it's okay. People will tell you throughout your lives, this is a fact, but it's not. Everything that we know, actually, there are some things which are facts, but most things are opinions, models, or theories. And, you do the best you can. But if you present it as a fact, then you don't see the world for really what it is. You accept what other people have told you, and you don't really live. You can really explore the world by seeing the wonder in stuff around you by asking questions.
yeah, I mean, you're completely right. And I think that the solution to this and making sure that your job is facilitated and reach out to more souls is through empowering and providing professional development to educators so that they don't fear, because sometimes they are the first obstacle because they think they've been educated that this is not for me. So yeah, that is a part that is truly important. Wow, I am still amazed by everything that you achieved. You keep receiving amazing project. I have really enjoyed attending this program as a teacher. Amazing, great project for young minds to push a proper path. Edward, thank you for the wonderful presentation. This is Bonnie, who is part partly guilty for the success story and the work that she's been developing. Gustavo, is there questions on Facebook?
Yes, we have a question on Facebook by Ashvin Shenoy. Could undergraduate students in physics in India work on any research projects with LCO? And if so, how would they go about applying?
Yeah, so we actually have a partner in India. We have several partners in India. One particular partner targets undergraduate level students, and it's Priya Hassan. She runs a project called Shristi Astronomy, and she provides regular workshops to which train undergraduate level students and postgraduate level on doing more advanced data analysis. And so she has a bunch of time on LCO that is for this program. So if you're involved with her program, and it's free to be involved in that, she will provide you with a nicely scaffolded, nicely put together educational program with an investigation. And yeah, I think that's a way to start. But if you have ideas about larger scale programs, then please be in touch with me.
Okay, thanks, Edward. I no more questions here for the moment. I just let you, Edward, let me ask you, make a comment, and then we can also comment on that. It's about the archive, because the archive is public, right?
Yep.
So myself, I think this archive is a very powerful tool for people to learn how to use astronomical data. We have several tools that anyone can, open those images and learn how to make color images or time lapses. So if you can just tell people a bit more about the archive and how can they access it?
Yeah, so the LCO archive is totally public for educational data. For scientific data that's older than 1 year, it's also public, but there's a proprietary period of 1 year on scientific data to allow the scientists to try and write their papers on that. I don't have any control over that. But there is in excess of 10 years worth of data in this archive, and you can search this archive very simply by target. So if you have a target that you want to do some sort of time series or long-term monitoring on, you can have a look in our archive for data, historical data of that target. You can also find images of targets that say you don't necessarily need an up-to-date image. You can pick the best images that other people have taken of a target. If you wanted to do not some data analysis, but to do some astrophotography, you could do that cherry picking. But we also have a lot of things like complete exoplanet transit curves, complete life curves for objects that are in our archive. So it is a huge wealth of data in there. Now, the problem is knowing where to get the good data and how to sort the good data from the bad or incomplete data. And that is a problem because to really achieve this type of use of the archive, we really need to know which data, otherwise you have to go back and find it. And that is a problem that I don't have an answer for. But please do look in the archive if you want some astronomical data and you have a target in mind. We do have a huge amount, and it's just archive.lco.global. You don't need a login or anything.
Yeah, thanks, Edward. That's really the point. You don't even need the login, so it's really up for everyone.
Yeah.
Okay, are there any other questions here? Let me check on Facebook again. But I got a thank you from
No, I
Ashwin?
think this
Yeah.
was such a nice opening of GHOU, really. I'm